Welcome, everybody. We'll be talking GraphQL, but first let us introduce ourselves. My name is Santanu Bose. I work for Warner Media. I manage a Drupal development team, and we have Scott Jordan. Scott is a technical lead, and Eddie Slayton. Eddie is a principal architect at NBA. And Warner Media, you probably know, it used to be called Turner, and we are the parent company of CNN, TBS, TNT, NBA, NCAA, different brands. So we'll go over some interesting GraphQL things there. And this is our agenda. We first will kind of talk about the basics of GraphQL. Let me see how many of you have used or kind of know about GraphQL. All right, that's good. It's pretty much everybody. So maybe you already will be familiar with the basics. I'll just go through it quickly. Then Scott is going to talk about the GraphQL and JSON API, where we found an approach of combining best of both worlds, JSON API from Drupal and Node.js GraphQL, and how it works together. We'll go over some rationale behind it and how we put it together and what we did that's not out of the box. Then Eddie is going to talk about GraphQL at scale, and Eddie has some very interesting stories where you'll see in real life where GraphQL was the big saver of the day and how it all worked out, what strategies Eddie used to scale things at CNN. So let me jump into the basics. So what is GraphQL? I think we all know it's a API query language. And then also there's some information about this really becoming very popular in the industry, a lot of adoption in Drupal itself. But besides Drupal, there are many software development platforms that are really adopting GraphQL as the way to query APIs. So started back in Facebook in 2012. Facebook used it as an internal query language for their application. That's where it all started. Then they open sourced it in 2015. And then adoption started from that. And CNN was actually an early adopter of it. And Eddie will mention that, and I think CNN started it 2016, right? Around 2016, they started on that path. Then wider adoption started in 2018. And between 2018 and 19, there was probably like about a 40% increase in Drupal community itself of adoption of GraphQL. That's why we feel it's so important that everybody is kind of like getting into that GraphQL land. We just do some sessions and share some experiments that we ran into. Then benefits. The benefits are, of course, like clients can specify exactly what they want and how they want it. Nothing more, nothing less. And the structure is also very friendly with the applications or apps that will be consuming the query in output. So that's really helpful. Then also you get fewer back and forth because you can get things in one step instead of many steps to piece your data together to make sense of it. And for these reasons also, versioning is not so much needed anymore because you can have apps asking for different kinds of information, and from the same structure that you have put together, you can support multiple outputs, essentially removing the need for versioning your backend APIs. So to show that in a context, I borrowed some information from this howtographql.com site, and they have a very nice, interesting demo and tutorial to bring it all together. So here, for example, maybe we are trying to query some information like the name and then the posts by that person and also the followers of that person. That's what we're trying to get. That's what we need to build our apps. So we'll first see how you do that through REST API. So this is what it will look like. First, you'll do a trip to get the user information. Then you'll do a second trip to get the post, and then the third trip to get the followers. And notice also that we have so many additional items. Maybe it's not very clear from here because of the resolution, but we are showing that we have ID, the name, address, birthday, a lot of other additional stuff that you're getting from the server that you don't really care about. And those things become significant when you're dealing with a mobile application or something that could be bandwidth constrained. So with all these things with the REST API, GraphQL has this way to get the data. You have one query that shows exactly what you need, and then it comes back together from the server side, and then you get exactly the items that you are looking for, nothing more, nothing less. And so it solved the too many round trip problem, and it also gives you the data exactly how you need it. So that's the beauty of GraphQL. That's why developers really love it, and also it's very performant for applications. Then by looking at it, it might be looking like GraphQL is only for query, but that's not entirely true, because query is definitely the core emphasis of GraphQL, but you can also do mutation, by which you can change your data. So you can do modify, you can do create with GraphQL. And subscription is for real-time push. You can push data to client in real time using GraphQL. So whenever the output of our query changes, you can update that to the client. And also remember, it's very efficient in terms of bandwidth. So even if you're pushing to multiple clients, you're only pushing very limited amount of data. So that's the other benefit there. Then when we started learning GraphQL, we saw there are some key concepts that are very useful about learning GraphQL, so I just noted them down. Of course, you can Google it, there'll be a lot of articles, but if you master these concepts, then like a good idea about the whole ecosystem, how it all works together. So to get to some basic points, like client is something that's on the app or maybe on the JavaScript side that is working for caching and also creating this GraphQL query, because you have to kind of put it all together in a nice query, and the client helps with that. Then on the server side is to responding to the query that the client will send. Something has to get all the data and put it together. And aggregating data is to get data from multiple sources. Some source could be Drupal, some source could be other things like MongoDB database. If your data in a different system, you can piece everything together and respond back. And Eddie actually is going to talk about that too in some context, how this could be useful. Then schema is really the central benefit of GraphQL, where you can really fully describe the data that you are supporting on the server side. You can specify the type of the data, you can specify how the data is structured, how one piece of the data is related to the other piece. So that's the real benefit of the schema. And you can use the schema to also self-generate documentation. That's tremendously helpful to discover what is it there that you can query and how you can drill down into the tree to understand a complex set of items in a tree format. Then you can also use it to validate your data. Like when you're making queries or when you can generate something, then you can use schema to validate your data. That's really beneficial for queries. And resolvers are used to fetch data. So when you have this different kind of sources, you can use different resolvers to fetch different kinds of data and piece it together. So with those basic topics, we saw that GraphQL is not the only thing that solves some of these problems, because there is also an alternative in JSON API where you can solve some of these problems. And Rise wrote a very nice article to compare JSON API and GraphQL. And he also compared REST API, but I think we all know the REST API has a lot of trouble, so I just didn't put that in here. So I referenced Rise article here. You can see this information in a lot more depth. He actually analyzed every single thing that we have here like request efficiency, ad discovery, API discovery, etc. And he went into like 4 different things within each of them to kind of really compare and contrast the differences between them. So it's really a very good read. Look at it. But I try to summarize, the main key points here. So it seems the request efficiency, which is how many round trips you're making and how you are getting your data together. JSON API and GraphQL, they both have pretty good solutions. So they are kind of excellent on both. And API discovery is how you know what is there to query. And that's where GraphQL really shines. And that's what Rise also said, that that's one area where GraphQL is really outstanding in terms of self-describing document, in terms of interactive way to build your query. And I'll show you one example. So that's where GraphQL is really interesting. Operational simplicity is deploying, installing, then also running it. GraphQL has some caching considerations because in HTTP, caching GET is easy, but POST is, nobody really has done that before. But Eddie is going to, break that barrier for us, how we can do that. So the summary is that although there are some issues if you are just using things out of the box, but there are some clever strategies to get around that. And we'll talk about that. So I see this as a way, there's ways to avoid this caching issues. Then in terms of writing data back, Dry's opinion is that GraphQL requires some extra work, which is true because you have to write your resolvers to write data back to the back end. But for JSON API, it knows what entities and other data is behind it. It can do its thing to update the data. But at the same time, I could also say that GraphQL gives you extra power because if you have different types of data, maybe everything is not in Drupal, then GraphQL has a way to help you by writing your own resolvers. So it comes at a cost, but also has some advantages. And another thing that Rise also called out is that GraphQL has a bulk update available, but JSON API doesn't have that, at least at the time of the writing of that document. But it seems to be coming up soon in JSON API. But that's something to consider if you are thinking of bulk updates. The other item, subscription, Rise didn't mention that, but I felt that it's pretty interesting to call out because I didn't see any JSON API implementation of subscriptions, but GraphQL does have a nice subscription to update apps. So that's an interesting observation there. Then with that, I'm going to do a quick demo. If my Wi-Fi cooperates, we'll see. Is it cooperating? If it doesn't, I'll give up. What's happening? It was working before, right? It was. Yeah. Anyway, I think it's time to give up. So what I could show you is that there's a Twitter public API. And then with that, we could bring up an interface called GraphQL, where you could show the query on the left side, and then you could type it in, and you can explore what are the items to query. You could see the documentation, and to drill down like the details of a structure and see more items that you could discover. So unfortunately, I had some limitation here, so I'll just give up. I tried my cell phone's hotspot. That didn't work before either. Oh, okay. We're having trouble finding that site. I don't know. Okay. Okay, I think I'll give up now. So I'll go to the next one, and that's Scott. Okay.
I'm Scott Jordan. I am a developer at Warner Media, and my group, we support all the different sites that Warner Media has, and we develop Drupal modules for those brands to use, anything that's shared between the brands. And so one of the things we started looking at is how we can use GraphQL with some of these websites. So we started looking at it, and the first thing we looked at was just using the Drupal GraphQL module. There is a module available, but we started seeing some limitations with it. First and foremost, it still does not have a stable release. There's a 3.0 release candidate that's out, but again, it's a release candidate, and it's not really being worked on much anymore. Most of the work has gone to the 4.0 version, but it is still an alpha release, and it's not backward compatible with 3.0. And we also noticed some differences between the Drupal module and how GraphQL works in, say, a node environment, and that's how basically the schema is built. To query in Drupal, you use node and entity query format. The conditions, you have to know things about the format of node and query entity. It uses fragments for its entity references. If a piece of content has an entity reference to another type of entity, it creates a fragment, and then you have to use the fragment in your query. There's no subscription support in the GraphQL Drupal module. There are mutations. You can do mutations through a plugin architecture, but you got to use PHP code to do it. Whereas a lot of GraphQL developers want to just use JavaScript because they're already familiar with that. And so that was another requirement, is make it easier for web developers who are already familiar with JavaScript. So then we started looking, well, how can we get the data from Drupal into a GraphQL environment and get rid of some of these? So we started looking at pulling the data through JSON API. And the good things about JSON API is it's the recommended headless way. It is now a part of core in Drupal, so there's no problems with using alpha versions or anything. It gives us a way. There's APIs in there where you can get a list of all the content types, and we can drill in and get details about that content type through the API. Also, JSON API does some caching of the Drupal entities, whereas we mentioned caching in GraphQL can be a little hard to do sometimes. And under light load, this might be a solution where you just let JSON API do the caching and use that instead of the GraphQL. There's also another module that we looked at that's JSON API extras. And what that does is allow us to do things like disable and enable resources. If we don't want the GraphQL queries to see all our content types, we can disable them. If we want to use a different field name, we can just change that in JSON API instead of having to go into GraphQL and change our schema or rewrite our schema. You also use things like field aliases, again, renaming things. You can change the path of the JSON API call also. So we started with that, and then we came up with this little simple architecture of how to do this. So what we've got a Node.js running, and inside of that we're running, first of all, Express GraphQL. Express GraphQL is a pretty common GraphQL server for Node.js. And then we use a couple of cool tools called GraphQL Compose and GraphQL Compose JSON. GraphQL Compose is a toolkit that has APIs for creating schemas and resolvers. And it basically lets us take our data and using the plugin GraphQL Compose JSON, we can just pass the blob that we got back from the JSON API call, and it does 90% of the work we need to create our schema. It creates all the fields. It gives us an easy way to start doing resolvers. And as you can see, that makes HTTP calls down to Drupal, which use JSON API and JSON API extras. So I'm going to show you a little bit about how that looks. So first thing you see is this is just, we're playing around with the basic article here. You can see we've got a couple of fields, the body and comments. Then we have image and tags fields. Both of those are in JSON API, they become entity references. So again, that's been a problem in Drupal, in the GraphQL module in Drupal. Entity references is a little complicated. So we'll see later that our solution maybe makes that a little bit easier. But you can see there's the image and tag field that entity references. The first thing we do is we're going to call JSON API. That's really boring. It's going to give us a list of all the content. So each of these is a content type, and it gives us a href back to JSON API to drill down and get the format of the content. And you see that looks like this. So we look in the node article here. You'll see got all the fields here, and then under the relationships we have the field image and field tags there. If we spin that, we can see we've got the links and the data back to it there. So we've got a schema builder that what it does is it goes through all those content types, and for each of the content types, it's going to go in and it's going to add a couple of resolvers in queries. So it's going to add a resolver that gets one piece of content by ID, and it's going to add another query that gets all those content types with a couple of parameters where you can pass in a limit and an offset. So this is what it looks like after the schema is built. You can see over here in the schema query, these are the types that I had exposed through JSON API extras. You can see there's node article here, which is what we were looking at. It takes an ID as a parameter and returns a node article. All of this was built by the GraphQL composed JSON. It returns a list of attributes, and you can see there are fields, the body and the comment. And if we go back one, we'll see that the field image and field tags that are there. So we can do simple queries like here. We're going to get all the node articles, and we're going to get the ID and title for those. And you see it returns the whole list. We can start adding things that our query built, like a limit, if we only want to see 5 of those. And there we get the list of 5. We can also start looking at some of the entity reference fields. We see there's the field image field, and we can, from that, we can get the attributes, and from that, we can get things like the file name. And if we run that, we'll see there's the field image and the file mime type there that we requested. So that's about it for me. Oh, one more thing. Some of the things that this allows us to do that were not in the demo but could easily be added on are things like mutations, filters, fragments. You can do subscriptions or federated graphs. One thing about this demo is, again, it was making calls back to Drupal using JSON API. There's other GraphQL Compose plugins, and you could do things like use module called Any Change Notifier, which will push your changes up to other systems, or even like the Elasticsearch search API to put your data in Elasticsearch, and then instead of using JSON API, you can use the Elasticsearch query and grab the data out of that, and that maybe be better performance than calling Drupal back every time. So now that's it for me, and I'm gonna turn it over to.
Hello, everyone. Hello. All right, great. I'm here to talk about GraphQL at scale. First, I'm going to give you a little information about myself. I know Drupal is a big deal at Warner Media, and I'm going to give you a couple of things. I'm going to give you a couple of stories about how we use Drupal or GraphQL at CNN and the next evolution with NBA. And most of my experience with GraphQL has been with CNN and CNN.com, and the next evolution is going to be with NBA. So I'm going to talk about massive scale. Again, Santanu mentioned that GraphQL was introduced as an open source product by Facebook in 2015. And in 2016, we began to develop against GraphQL. At CNN, performance is, just like your sites, are very important All right, speed is like a critical measure in regards to how the user experiences your site. And there are multiple things that can contribute to speed, but we wanted to impact the things that we could control. Because we deal with a multi-complex organism, which is the CNN product team, we had to get buy-in. And how do you prove buy-in? You prove buy-in with data. So we decided to look at the most simplest component that we can control, which was the weather. So we decided to impact the homepage of CNN.com with this weather widget. And what is this weather widget? Using a REST request, we would request 7 days of forecast just to show you a temperature and an icon. 7 days of forecast just to show you the temperature and the icon with a REST call. And we knew that we could, based on the promise of GraphQL, limit that request. That REST request was over 16,000 bytes just to show you an icon and a temperature. And with the graph request, we were able to prove locally that we can get that down to about 142 bytes. Okay, that's well and good. Now, how do you actually prove this in production? Production is where you prove that the metal hits the road at that point. So we took the challenge of putting this component on the CNN homepage on one of the biggest nights in America, in the world, which is election night, which was the election night of 2016. We were able to prove, using this graph request, we were taking about 16 million requests per hour with about a 96% cache hit ratio. And that was about 20 requests per second to the origin. And this was, at the time, we were just using all GET requests. And those were URI parameters in the request. Okay, you were able to prove that. But we, at CNN and any other place, we want to get more complex. Okay, you've shown us the weather. What about doing other things? So we wanted to prove that we could start returning other content types. So in 2017, we began to develop what's called the CNN Data API. We switched to Apollo Server. We were able to develop more complex queries, and we wanted to solve something around schema stitching. The problem with GET requests is that you're limited by character count. We were let's say about 2,000. And with these complex queries, they can get more, the requests will become larger than that. So the alternative is post request. We have a GET request, we know how to cache that. Everyone understands how to cache that at the CDN, you know how to cache that in the back end, you know how to cache it in the applications. But what about post requests? So how many of you have operated on a site that takes 5,000 requests per second or more? How about 10,000 requests? How about getting up to 50,000 requests per second? Or even burst up to 100,000 requests per second? Those are the type of numbers that CNN gets on a daily basis. Imagine a breaking news event, that can spike even further. So with the post request, we were able to you can get up to 8K. Okay, that's reasonable, but we all know with all the requirements that come down from product, you can go well beyond 8K, especially as technology evolves. So how do you develop a solution that's agnostic of those limits? So that's what we developed. We took it to keep it simple, a measure. We stated, hey, we know that the post body would change. Why not just use the hash of the post body? Okay, that seems reasonable. So we took an MD5 of the hash. So we asked all clients who's gonna request our data, you have the MD5 or hash in some way your post request. A simple approach is MD5 hash it. So if it changes, the hash will change. If it doesn't change, the hash won't change. You pass it as a header. We have a specific header that you pass. It is noted here. You're required to pass that with your API key, and we can cache that at the edge in the CDN. You can post requests all day long. So let's party. So how did this operate? So on an average day, which was September 2018, these are the numbers I grabbed. So we were taking about 7.6 million requests per hour at an 89% cache hit ratio, and that's about 27 requests per second on post request to the origin. Post request. So now you're seeing, you may, as you go out and start to operate against GraphQL, you'll start seeing CDNs. They're starting to operate on a model of, hey, we can cache your posts. They're doing something very similar. But we were doing that before they caught on. The key takeaway is we're not bound by URL limits. We're not bound by the post body cache limits. We're CDN agnostic. We can work with Akamai, we work with Fastly, we can work with CloudFront, whatever CDN provider, your own CDN is agnostic of that. You still have to be smart. You're still open to DDoS attacks, right? If someone understands how you operate, they can figure out a way to increment that MD5 hash. So you got to be smart about that. So we have mechanisms in place to help us to deal with that. So security still needs to be top of mind, even though you can cache the post bodies. So the next step. All right, okay, we can do that. We can serve multiple content types to multiple platforms. And so, okay, I told you that these companies, they get more sophisticated. All right, you can serve a content to web. All right, now how can you get this to mobile apps? How can you get this to the next platform? Because how many of you operate with distributed teams? You have a team in like a different country or a different part of the state. Okay. So with GraphQL, you have this mechanism called schema stitching. So we wanted our teams who are distributed to still be able to be distributed and operate and work efficiently without impacting performance. As at the beginning, I mentioned that we were talking about page speed. That still has to be top of mind. We know that our consumer platforms are requesting multiple content types, articles, video, images, what have you. So how do you allow the video team to operate? How do you allow the team that works on images and optimizing images to work in separate silos but come together and still be smart about performance? So we utilize schema stitching inside of GraphQL. And what does that mean? It's a fancy word for a join. So we do joins with GraphQL. So each team writes their graph service, and we have an overarching graph service, which is the CNN data API, for instance. It allows a team that works on the CMS to do their thing in graph. It allows a search API team to do their magic in graph. It allows a tagging team, a content team to operate in their own silos, but they come together in graph, the way it works. And I'll show you how you can use this extend type to bring those different bits together. So before the Apollo team introduced the federation service, it's really doing a lot of this. So we went in and actually manually added different stitch points based on certain parameters, but it still it does the same type of thing that the federation does with Apollo. So as I mentioned, we were using the extend type. For instance, we have an article and we want to add tagging to that. So you extend an article, we have this meta tag or Google Knowledge Graph tag. These are two separate services operated by two separate teams, but they can impact an article. This mechanism here will allow you to tag an article, tag a video content, you can tag an image, you can tag VR, you can tag AR, you can tag whatever new piece of content that comes down the pipe in a consistent way without going in and getting the requirement of, hey, I want to add this new widget to the homepage. Now you don't have to scramble and every part of the organization has to come together to build a new widget for the homepage. You can just build a new widget. In this case, an article, a video, or a gallery type. And you can still tag those in a consistent way. So beyond the extend, you have in your resolvers, which Santanu and Scott mentioned, you have to just write your resolver. So for the article, you have this tagging article, this tagging resolver. And here, since we're doing it manually, we tag and do the operation on the fragment. The point being is you still are able to tag the content. The articles team can do what they do in regards to formulating the body of the article. Then you actually separate the concerns so that you have a presentation tier that can operate on presentation. And the data team can just work on data. And what does that do? That allows any new client that comes about, the next iPhone, the next iPad, the next full widget that comes about with this viewport size of X, it doesn't matter to this. You just request the data, and you can just do the presentation however you want. So you're decoupling presentation and from data, but you still get the same consistency. An article is an article is an article. The tagging is the tag, no matter where you are. So you understand how an article is performing on web, mobile apps, desktop, what have you. Television, Roku, Xbox, it doesn't matter. So the takeaway. The schema stitching allows for teams to separate the concerns, as I mentioned, and they can still operate in their own sandbox. However, the way we did it, it required manual work. So a team would go in and create their graph service, and then they would do a pull request to the overarching graph service to stitch in their piece. It was very limited, but they still had to go in and do that work. The world was happy and everyone can party. Now we can go innovate, right? So we're not worried about building a whole entire stack just to serve a new widget. You can just build a widget. I'm going to talk about evolution. Now, this isn't necessarily about Drupal or GraphQL. As I mentioned, I was with CNN about almost 8 years, doing a whole lot of different things, fantastic things, which were exciting. Now I'm taking that over to NBA, and what the next experience for you or those who are fans of the NBA and sports, what does that mean? Now I understand how to deliver news. Now how do we integrate that with sports? How do we make sports and deliver a different experience? So I'm in the process, for those who are going into new situations and you're trying to influence, how do you do that? You have to listen, be empathetic, and tell a compelling story. So I'm at step 0. I'm listening, I'm being empathetic, and I'm starting slowly to tell a compelling story. And part of that, telling a compelling story, is getting in front of you and introducing you to new concepts and ideas. So right now, step 1, I'm understanding the models. So how do you operate? Okay, what problem are you trying to solve? So some of the things I'm going to start introducing based on the learnings are the introduction of the Schema Federation tool, which Apollo has introduced, which allows you to write your models, and then the Federation tool will allow you it will dynamically create the stitch points without you actually going in and manually doing it. And you can publish a schema, so it'll listen for your schema, and as you integrate your schemas, it just knows how to party. Authenticating mutations. What does that mean in regards to how do you change the data based on a user's preferences? How do you use subscriptions? So I actually had a story in here about how I was using real-time data, but in the interest of time, I took it out. But the gist of it was I was using server-sent events to do near real-time communication. For instance, there's a breaking news event. Let's say something happened in the world and everyone's going to CNN.com or CNN, whatever CNN platform, and they want to get the latest and greatest update without refreshing their content or refreshing their page or refreshing their device. We built a mechanism using GraphQL and a mechanism called request collapsing with Fastly, where we're able to, as an editorial team, made a change, we were able to get that communication out. And we weren't using WebSockets, we were using server-sent events over HTTP 2. And so the next step is we're building a video streams API. As I mentioned, I was starting to tell a compelling story. And part of that compelling story with NBA is to build out this video API. Imagine a world where you have an API specific for this one side of the organization, but it's affecting the same video just for the one platform. It's the same video. Why is it being treated differently on web than mobile app or in the VR device? Why? If we want to get a unified experience no matter where you are, why are we treating it differently if we want a unified experience? If we want our fans to be engaged, this is how we do it. So we're starting there. All right, I know I went fast and I said a lot, and you probably have some questions. These are some resources that we use in our presentation today. You feel free to take it down, but for the most part, we're GraphQL.org, some Fastly bits, some Datadog bits, how to GraphQL. And if any of us, you can come ask us for any of this stuff, and we'll definitely share it with you. But for some key takeaways, and then we'll open it up to some questions because I know we have a couple minutes. This is a bold statement. I was kind of like hesitant. I'm like, oh man, GraphQL is better than REST. Now, as you see, there's a statement at the end. I'll qualify that. All right, GraphQL is better than REST. With GraphQL, you can query, add, and modify data. With Graph, you can subscribe in real-time updates with subscriptions. We showed you how to combine Drupal and the JSON API with Node to create a graph service. And we showed you how to scale Graph. So my qualifier for number one is there is not one hammer for every nail. Know the problem that you're trying to solve. Engineer solutions as a means to an end. Yes, we say GraphQL is better than REST, but it's not for every situation. Right? It's the cool kid. You have all these cool technologies, and we tend to jump from cool technology. Use the best tool for the job, but have a larger goal in mind, not just the problem you're trying to solve right now. And that's a problem or a mantra that I take as an architect on a daily basis at Warner Media. And no matter where I speak, that's the mantra I take. Look at the larger solution, look at the larger problem, not just focusing on, hey, I got to get this task done just to deliver this product. Thank you. Any questions? You can find us here on LinkedIn. Actually, all three of us, AD Slayton. No matter on LinkedIn, Twitter, Facebook, wherever, I'm AD Slayton. So if you see AD Slayton, more than likely it's me. You have Santanu, he's on LinkedIn. You have Scott on LinkedIn, and these are our URLs. So that's your hand?
Yes. Let me start with your question, which was for the GraphQL services you're talking about. So you're hitting the GraphQL service directly from the client side. So
yeah, absolutely. So we have the architecture is you have the client, you have the CDN, you have an API gateway, and then you have Graph.
And then so for the data size, I guess that 8K limit came in with when you were trying to expand it to more stuff.
Right.
I'm confused about that. Like you reduced the data size to.
So as the post request, let's say as you're crafting when Scott was showing you the UI when he was crafting the graph queries, that you actually post that to our service, and you can create some exotic queries that get large, just to retrieve maybe 3 bytes of information. But the post to us is going to can get large. So that's what that limit is.
Right. I think you could try with GET, but pretty soon you'll see that all these servers don't allow GET requests beyond certain point. On the server side, there's probably like 8K limitation, but also browsers impose some limit on the GET request, so you may get chopped up, by the browser too. So that's why you have to go to post, and then how you cache post. That's why you have the header solution.
I guess. What I'm trying to wrap my head around is like how your simple. So if your response is relatively small, then how your client request ends up being so large to generate.
So you may have some fragments inside of your graph query. You may have to dive deep into. Let's say you want a particular element out of a video or an image, but that image may be embedded in the body of an article. So you have to traverse that in your query.
So this is a very different scenario than the web example.
Right. So
was very small.
So
right.
you could.
So that didn't work.
Right. So let's for in some use cases, to your point, you can request an entire page the articles, the body, the video, all in one request. And that can make that query huge. Right, and you'll still get all that data returned to you, but the post body just be huge.
So how do you handle caching on the GraphQL side, or do you cache it in a different spot?
So there are a couple of ways you were doing it. So I was not caching at all on the back end side with Graph. It was, as it came to the origin responded. Now, all my caching was at the CDN on the hash key. Now you can use something like Cache Manager or Redis on the application side, just to request to cache those queries. So when the request comes down, you're just fulfilling it from Redis or Cache Manager versus actually doing those operations, right?
So I mean, as you saw, like in 27 requests per second instead of like maybe 1 million requests per second, that's a huge difference, right? So origin hits are so small, right? It's like for a site like CNN, you have 27 requests per second, which is nothing.
So with Fastly, it was the CDN, and the way it was working is if they use this thing called request collapsing. And if you're getting 30,000 requests, only one of those requests, they're going to hold on to 29,999 and only send one to the origin. And you fulfill that one, and then they send it out. So that's how we were able to utilize the service and event, because it operates the same way. You'll get 100,000 requests, only one is going to come down. They're going to hold that and fulfill it and send it out to everybody.
But the strategy is pretty generic, right? We can use it on Akamai also, right? So
Well, Akamai, actually you can't. Akamai does not. I was just in a conversation with them in regards to the service sent event part. So we're going to be working on that.
Okay.
And validating that actually can work on their side.
But the post request would be okay. Right?
But the post request, the post request stuff, it's agnostic, right? In regards to the solution was to be agnostic. We didn't want to care about, hey, we were with Fastly or Akamai or CloudFront. We just wanted to know we can cache at a certain way, agnostic of CNN or CDN.
Right. And on top of that, if you're using Drupal, you can use like standard, like Redis or something for your cache, and then also Varnish if you need to. There are other layers you can build in. But because of the CDN, the hits will be so low, we have to see whether you really need it or not.
Right. If you cache right, man, you can party on the back end. You can shut it down, and just everything coming from CDN, right? That's how you can do. All right. That's how you can work with it. Like if you're doing serverless or with lambdas. If you're caching right, you just shut it down on the back end, and then when a new request come on, then you just make it live again with the lambdas, right? You can take it there.
Yeah. Any other question?
I have a follow-up then. So going back to kind of towards the beginning of this, you were talking about how now you're actually using Drupal, the JSON API as the face to Drupal, interface to Drupal with GraphQL. In the previous talk with Gatsby, we kind of saw a similar thing where you were turning on JSON API and Gatsby is generating the GraphQL interface from Drupal. I was curious if you explore that and like what the, I guess how does this solution compare with the way that the Gatsby solution?
Sure, Gatsby is for generating static sites out of it, right? So, that way you have a pipeline they have established where you use, I think they also use GraphQL. So to get that and then generate the static site. I don't know whether they handle the nested relationships or not. That part we have to check. I don't know. It's possible they do, but we did some special coding to solve that. Because if you look at a JSON API output, when you have a relationship, you'll just say that this thing relates to that. You don't know anything more than that. But we wrote code to generate schema out of it. So we can just materialize the entire thing. You don't have to do back and forth to get your stuff. So that's what Scott was showing, that you have the entire thing done in a schema that you can use. And Gatsby kind of needs to work in the Gatsby ecosystem to generate a static page, but here you can do whatever you want with that GraphQL. You can have your Node.js app that does not do static generation, does some other things. So you are totally open to that. And also I might say that with this solution, it's probably hardwired into JSON API. You don't have ways to get into the guts of it to write resolvers to go to MongoDB or some other data sources. But this mechanism is very generic. It can give you entire power to your disposal. You can have your resolvers and other things to craft your data from different sources as you need it. Yeah. But to be honest, I'll give you a disclaimer that I have not entirely seen the internals of Gatsby. This is like from an outsider. This is what I feel, but maybe take it with some grain of salt, like research, to see how they are really doing it.
Okay, the schemas that you're talking about, so you would, is that something you would generate once, or like generate, you build the, enable the JSON API and then build a schema off of what it's producing? And then that schema would be used to generate feature requests?
You can do that. Actually, you can just do your schema on your own without looking at JSON API or anything. You can just, GraphQL schema is a structure that you can generate. But with this GraphQL Compose and GraphQL Compose JSON, you have the benefit of generating schema on the fly. You have that capability that it can look at the JSON API and it can generate the schema for you. That way, it may give you some dynamic capability, but you can also use it as a...
Yeah, so what happens is you start the server up, you start up the new process, the process will run just the GraphQL Compose, and it will dynamically create the resolvers and all that on startup. So if you're going in and your service is restarting all the time, it's going to constantly be doing that. Right? So unless you have some eventing mechanism that you can hook into and the event on change, it will update the compose part. But it's going to do that every time you start it up.
Right. But you can also go out on your own to
you can on your own, right?
Use that, whatever they're doing as a starting point for your schema, or you can hand code your schema because GraphQL Compose gives you tools to build your own schema. Yeah. And that's what we kind of did to kind of like fill in the gaps that did not come from straight introspection. Because JSON API the GraphQL Compose looked at the JSON API output. It did not know what to do with the relationships because it saw relationship as one field. It did not know that you have to traverse the referenced item to build that part of the schema. And that part we did using this schema building tool. So that's why there's some nuances to it, and that's why you have to do some extra coding to do things on the fly. But you don't have to always do that. You can just use initially to generate your schema, save the schema, do however way you want to generate it. Good questions. Yeah. I think John, you had a question? No. All right. Thank you. All right. Thanks everybody. Thank you.